All right, guys, we're going to be finding the area of rhombus ABCD, and it gives us some information. It says that the diagonal is 16 inches. So I'm going to go ahead and draw on that diagonal of 16 from A to C, which is 16 inches. And then it says that CB is 10 inches. So CB is 10 inches. One thing that we need to know about rhombuses, first of all, is that all the sides are exactly the same. So that is 10 inches all the way around. And so that would make the perimeter really easy to find. But we're not looking for the perimeter. We are looking for the area. Now, one thing about parallelograms is the area of a parallelogram is equal to the base and the height. The problem is in this problem, we don't necessarily have the base and height because we're not giving a 90-degree angle on two measurements. So we're going to go about this a different way. It does give us a diagonal, and so what I'm going to do is I'm going to draw in the other diagonal, because one of the things that we know about the diagonals of a rhombus is they bisect each other, meaning they cut each other in half. So that 16 there actually gets cut in half by the other diagonal, making it an 8-inch and an 8-inch piece. And what you're going to notice is we have these really nice triangles that are formed. We have a triangle, and all four of those triangles are in fact congruent to each other. And one of the great things about a rhombus is that when they intersect, when those diagonals intersect, they form a 90-degree angle. And because they form a 90-degree angle, when it comes to the area of this, we can actually find the area of the triangle. And because all the triangles are exactly the same, we can take that triangle and multiply it by 4. So that's what we are going to do. We're going to find the area of that triangle. If we remember, the area of a triangle is equal to 1/2 the base times the height. And the base and the height must form a 90-degree angle. And that 90-degree angle is there. So we are actually missing the side that we need. Okay, that little X side right there. So we are going to find the side of a right triangle, which we know is the Pythagorean theorem. A squared plus B squared equals to C squared. And A and B are going to be 8 and X because they form that 90-degree angle. And C is going to be 10 because it is the hypotenuse or across from that 90-degree angle. And so we just do a little bit of math. 8 squared is 64. X squared equals to 100 because 10 squared is 100. We're going to subtract the 64. Okay, and X squared will be 36. And then we'll take the square root. X will become a value of 6. So in our rhombus, what we know is automatically is that little value right here is the value of 6, okay? Now, we know that we have the length and the width of this right triangle, so all we need to do is come back and find the area of that triangle. So area of that triangle is going to be 1/2 8 times 6, which is the same thing as 1/2 of 8 is 4 times 6, which is 24. And that will be the area of that triangle, which is 24 inches squared. Now, we're going to take that information because, as we had just said, the area of all 4 of the triangles that are being shown in this diagram are going to be congruent to each other. So all 4 of those are congruent to each other, those 4 triangles. So I'm going to take 24 and I'm going to multiply it by 4 to find the total. So 24 times 4, which is going to give us 96 square inches. And that is going to be the area of our rhombus in this case. 96 square inches is going to be our answer. All right, y'all. Hope that helps out. And hope you have a better understanding of working with rhombuses.